For the last two problems, we're given a situation, asked to create a tree diagram, and then from that tree diagram, we're supposed to list the full sample space. So the situation is we're going to play the game rock, paper, scissors 3 times. We want to define the simple events for the experiment. So basically, we're calling throwing rock R, paper P, and scissors S. When we have our initial first throw, we can go any of the 3 ways. We can go to rock, we can go to paper, or we can go to scissors. So this represents the first throw. From there, we can go to rock, paper, or scissors, rock, paper, or scissors, rock, paper, or scissors. This represents the second throw. From there, we can go rock, paper, scissors, 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 rock, paper, scissors. So this represents the third throw. Our goal now is to take the tree that we've made and list everything that happened in the full sample space. What really happened is we had 3 possibilities the first time. Coming off of that, we had 3 possibilities each of those, giving us 9. Then we had 3 possibilities off each of those, giving us 27 total things that we have to consider. It's a lot. The first thing we got to consider is tracing the tree to start. We had a first throw of R, second throw of R, third throw of R. So this first one would be represented as R, comma R, comma R. Second one, R, R, P. R, R, P. Then we have R, R, S, R, P, R, and so on. Instead of listing them up here next to the end of the branches, I'm going to list them in question 10 as the full sample space. This is the same way that a question like this is asked on Cengage and it wants you to enter it. Even though this is R1 for the first throw the way they say it, they don't want you to have subscripts on them. They just want to say, here's what went in the first throw, second, and third throw. So the one that you guys do on Cengage, I think there's only 2 options as opposed to 3. But basically, this is how they want them entered. So the first possibility is parentheses, R, comma, R, comma, R. And parentheses, then I'm going to put a comma to start the next possibility. That next possibility is R, R, P, then R, R, S. After that, we have the RPs, R, P, R, R, P, P, R, P, S. Finally, we have the RSs, R, S, R, R, S, P, R, S, S. That takes care of all the branches of the tree that start with rock. Now we look at the branches of the tree that start with paper. This goes paper, rock, rock, paper, rock, paper, paper, rock, scissors, and so on. So the branches of the tree that start with paper, P, R, R, P, R, P, P, R, S. Then we have the PPs, P, P, R, P, 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 S. And then finally in the P section we have the PSs. P, S, R, P, S, P, and P, S, S. Last thing we need to worry about is the ones that start with S. If I follow this branch, S, R, R, S, R, P, S, R, S, and so on. So this one starts off S, R, R, S, R, P, S, R, S, S, P, R, S, P, P, S, P, S. Then finally the SS's, S, S, R, S, S, P, and S, S, S. This is the entire possible sample space from this experiment where I'm going to play rock, paper, scissors 3 times. So if I wanted to pick an individual sample point, for instance this would represent I throw paper game 1, I throw paper game 2, I throw rock game 3. So I could look at this entire sample space and answer questions like what's the probability you throw rock the second time, what's the probability you get at least 2 rocks. There's a whole bunch of questions I can answer once I have this sample space written out.